Good day, everyone. Let us learn the geometric sum presented by Princess Romualdo, Blessy Riel Pastorite, and Jyan Carlo Magaso. But before that, let us find out first what the objectives are in our topic. Objective number 1. Define and introduce the concept of geometric sum. Number 2. Explain the process of geometric sum. And number 3. To demonstrate and explain the process of getting the sum of finite and infinite geometric sequences. To make it easier for you to understand, we are going to explain the topic in a simple way. Let's not wait any longer. Let's get started. It is important that we understand the meaning of geometric sum. So what is geometric sum? A geometric sum is the sum of the terms in a geometric sequence. Formula of geometric sequence. Formula A finite sequence. S sub n is equal to A sub 1 multiplied to 1 minus r raised to the power of n over 1 minus r. Finite sequence can be used if n is given. Formula B infinite sequence. S is equal to A sub 1 over 1 minus r. Infinite sequence can be only used if n is undefined. A sub 1 is the first term, r is the common ratio of every two successive terms, n is the number of terms, and the big letter s represents the undefined sum of a term that we are going to solve.
Here, we have the example problem of finite sequence. Problem number 1. Find the sum of the first 8 terms of geometric series if A sub 1 equals 1 and the common ratio is equals to 2. To find the sum of the first 8 terms of geometric sequence, you can use the formula for the sum of a finite geometric series, which is S sub n equals A sub 1 times 1 minus r to the n over 1 minus r. Now, as we can read in the problem, we are going to find the first 8 terms of geometric sequence, so the n is given, or n represents the 8th term in the problem. S sub 8 is equals to 1 multiply to 1 minus 2 raised to the power of 8 over 1 minus 2. Next, S sub 8 is now equal to 1 multiply to 1 minus 256 over negative 1. Next, S sub 8 is equal to 1 multiply to negative 255 over negative 1. And lastly, S sub 8 is equal to negative 255 over negative 1. And the result is S sub 8 is equal to positive 255. Therefore, the sum of the first 8 terms of geometric series is 255. Our problem number 2 is an example of infinite sequence. Problem number 2. Find the sum of the series 3, 6, 12, 24 with A sub 1 equals 3 and the common ratio is 2. To find the sum of an infinite geometric series, we can use the formula S equals A sub 1 over 1 minus R. In this case, A sub 1 is 3 and the common ratio is 2. Plugging these values into the formula, we have S is equal to 3 over 1 minus 2. Next, S is equal to 3 over negative 1. So the result when we divide 3 to negative 1 is negative 3. Therefore, the sum of the infinite geometric series 3, 6, 12, 24 is negative 3. we have here problem number 1. Problem number 1. Find the sum of the first 6 terms of geometric sequence 3, 9, 27, 81. In this case, so what formula we're going to use? We will use the formula of finite sequence since n is given. To find the sum of the first 6 terms of geometric sequence, we will use the finite sequence formula, which is given by S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. In this case, the first term is 3, the common ratio is 3, and the number of terms is 6, substituting these values into the formula. S sub 6 is equals to 3 times 1 minus 3 to the power of 6 over 1 minus 3. 3 to the power of 6 is 729. So, S sub 6 equals 3 times 1 minus 729 over negative 2. Next is 1 minus 729 is negative 728. So, 3 multiplied by negative 728 is negative 2,184. Lastly, when we divide negative 2,184 to negative 2, the answer is positive 1,092. Therefore, the sum of the first 6 terms of geometric sequence 3, 9, 27, 81 is positive 1,092. So now, let's going on to our last problem. We have problem number 2. Problem number 2. Find the sum of the infinite geometric series 2, 1, 0.5, 0.25. Okay, so what do you think the formula we're going to use? So we will use the formula of infinite sequence since n is undefined. In your series, the first term is 2 and the common ratio between consecutive terms is 0.5. Since each term is half of the previous term, now plug these values into the formula. S equals to 2 over 1 minus 0.5. S equals to 2 over 0.5. To simplify the expression, S equals to 2 over 1 minus 0.5. 1 minus 0.5 is 1, so 2 divided by 0.5 is 4. Therefore, the sum of the first 6 terms of geometric series 2, 1, 0.5, 0.25 is 4. But why is this important? Well, understanding geometric sums has practical application in various fields, from finance to physics. It's a tool for handling exponential growth and decay, among other things. In summary, geometric sums are more than just mathematical exercises. They're powerful problem-solving tools, whether you're tackling real-world challenges or exploring the pattern of our universe. This concept is a key to understanding. If you enjoy this journey into geometric sums, there's a world of math waiting to be explored. Dive deeper into this fascinating realm, and who knows what mysteries you'll uncover. Thank you for joining us in unraveling the world of geometric sums.